What the microbiologists and hygienists fear is that we will keep going with antibiotics, always trying to support or treat every disease with them without restraint. And that makes the germs stronger and stronger. The fear is that ultimately the germs will make all our antibiotics ineffective.
In 1928, Alexander Fleming from Scotland discovered a mold that killed pathogens. He called it penicillin. It came into its own during World War II due to the large number of wounded. The US put it into mass production. Fleming recognized early on that bacteria could become resistant to penicillin. When he received the Nobel Prize in 1945, he urged caution, but in vain.
Multi-resistant germs are not hospital germs. In our hospital and others, we found that over 95% of the people who are infected with these germs bring them from outside. You can't catch them in our hospital. That means that there is much to be done. And if we don't do anything, the problems will get worse and worse.
Antibiotic-resistant germs thrive wherever a lot of antibiotics are administered, such as in agriculture. The drugs can only kill the bacteria that are not resistant. The others multiply. Due to the widespread use of antibiotics in meat production, they also spread in animal stalls and manure. The University Hospital. Dr. Tina Boy uses bacteriophages to kill the germs. In Germany and many other European countries, these viruses have not yet been approved as a medical treatment.
For the past 3 years, we've tried in vain to remove the germs from Paulina's lungs with antibiotics. And so far, we've not been able to get them out completely. In the spring, friends told us about phage therapy. And after a long wait, we're finally here today. I hope the phages will bring us success in the next few weeks.
These viruses destroy bacteria. Paulina suffers from cystic fibrosis, a metabolic disease that makes her lung secretions thicker. This is why germs are always returning to her lungs. Among them are antibiotic-resistant bacteria. The doctors in Belgium hope to be able to destroy these germs using phages. To fight all the germs and to dissolve the secretion in her lungs, Paulina has to inhale several times a day, both with phages and antibiotics.
I think it's a good combination. The antibiotic doesn't harm the phages because they're viruses, and the phages don't harm the antibiotic.
The phages worked. Paulina finds it much easier to breathe. She finally feels like working out again. And exercise is good for her lungs.
And how much?
122.
She is doing much better, but doctors can still detect dangerous germs in her lungs. So she is considering going to Antwerp again with her father for another round of phage therapy. In Regensburg, molecular biologist Martin Griesel is looking for ways out of the antibiotic crisis. These have found a suitable bacterium. They multiply within it. During this phase, they produce enzymes. If enough enzymes are present, they cause the host bacterium to burst. And so Griesel produces these enzymes artificially, optimizing them to attack bacteria in the human body. He calls his invention artilysins. Streptococci are responsible for the milky cloudiness.
I've just made this Streptococcus germ solution. I'm about to add a control substance and our artilysins. To compare them, you will see that within 5 to 6 minutes, the cloudiness will be different. So the germs burst and are destroyed, and as a result, the solution loses its cloudiness.
A new approach like that provided by artificial enzymes is not without challenges.
If I come up with innovative approaches that have never been tested in humans, there's of course a certain risk, because they first have to prove their effectiveness in humans, and it takes time to develop them from scratch. But we have to say and believe there will be a solution, must be a solution, because the problem is so serious. How we proceed now will help us to keep these germs under control in the long term. We need to restrict prescription of antibiotics, preferably using the oldest drugs. We need good hygiene, taking swabs so we know who is infected with which germs, so we can act accordingly. And no matter what we can think of, the germs already have an answer.
These are some of the last photos of Simon Sparrow, taken just before the 18-month-old suddenly became ill and died. The cause of death, an antibiotic-resistant infection called MRSA. Scientists are predicting that by 2050, superbugs could kill 10 million people a year, more than the number who currently die from cancer.
Is this a battle or is this a war?
This is for that war.
A looming crisis blamed in part on the overuse of antibiotics. But here's what you can do. Only use antibiotics when necessary. Take the full prescription and keep vaccinations up to date.